2.5 million light-years away, close enough to feel like a neighbor across the street, the Andromeda Galaxy has spent over a decade quietly surrendering its secrets to the Hubble Space Telescope, and in July 2026, those secrets revealed something astronomers never expected. Through the painstaking FAT and FAST survey campaigns, images gathered between 2010 and 2022 resolved millions of individual stars into a single sweeping timeline, letting scientists read brightness, color, and density like tree rings to trace the galaxy's birth rate back hundreds of millions of years. And what they found was a spiral galaxy falling silent, its star formation collapsing over the last 500 million years while our own Milky Way keeps burning steady and bright. At the heart of this cooling giant lies one last blazing ring of Starbirth, 32,000 light-years from its core, the final ember of a galaxy sliding from youthful fire into quiet maturity. And the question driving this story is simple: why is Andromeda dying, and what does its fading light foretell for the galaxy we call home? Two and a half million light-years away, tilted just enough for us to see its full spiral face, Andromeda hangs in the night sky like a mirror we have never quite been able to read clearly. It is the closest large galaxy to our own, close enough that on a dark, clear night you can find it with nothing but your eyes, a smudge of light that is actually a trillion stars. For most of human history, it has been a symbol of distance and grandeur. In July 2026, it became something else entirely, a warning. That warning came from the Hubble Space Telescope, though not from a single dramatic snapshot. It came from patience. Between July 2010 and December 2022, astronomers pointed Hubble's advanced camera for surveys at Andromeda again and again, gathering light through two filters tuned to catch stars across a range of colors and brightness. This was the work behind the FAT and FAST surveys, led by researchers including J. Dalcanton and B. Williams, an effort that stitched together one of the most detailed portraits ever made of a galaxy beyond our own. Millions of individual stars, each one resolved, each one measured. From that raw starlight, astronomers can estimate a star's mass and age just from its brightness and color. And when you catalog enough of these stars across a galaxy's disk, patterns emerge. Dense clusters of young blue stars mark recent birth. Sparse, reddened populations speak of eras long past. Layer enough of these clues together, and you can reconstruct a star formation history stretching back hundreds of millions of years, written in the color and density of starlight itself. What that timeline revealed startled the scientists reading it. Star formation across Andromeda has slowed dramatically over the last 500 million years, a gradual dimming of the machinery that builds new suns. This stands in stark contrast to our own Milky Way, which has kept a comparatively steady rhythm of stellar birth over the same stretch of time. Two galaxies, similar in size and structure, moving toward radically different futures. That asymmetry is exactly the kind of detail that makes astronomers sit up and ask why. The answer, or at least the visible heartbeat still holding on, lies in a ring of star formations circling roughly 32,000 light-years from Andromeda's core. This ring appears to be the galaxy's last major engine of new starbirth, the place where gas still collapses, ignites, and gives rise to fresh stellar generations while the rest of the galaxy grows still. Picture that ring not as a static feature, but as a slow, grinding conveyor belt of gas and dust, sweeping material around Andromeda's midsection and compressing it into pockets dense enough to birth new stars. Astronomers sometimes call structures like this a starburst ring, though Andromeda's version is far less frantic than that term implies. It does not explode with new stars the way galaxies do after violent mergers. Instead, it smolders, a slow, steady contribution to a galaxy otherwise winding down. What makes this ring so significant is not just its location, but its persistence. While the rest of the galaxy has seen its star-forming regions fade one after another, this circle of activity has continued, almost stubbornly, to produce new stars far longer. Some researchers suspect its shape is linked to a past gravitational disturbance, perhaps a close pass by a satellite galaxy, stirring gas into this rotating structure. Others point to the possibility that it marks a boundary where density remains just high enough to sustain Starbirth, a last stronghold in a galaxy running out of raw material. Either way, the ring forces a deeper question. If it represents the final major source of new stars, what happens when it too begins to fade? Does it dissolve into a diffuse haze or collapse inward before flickering out entirely? The Hubble data does not yet answer that question, but it gives scientists a way to watch the process unfold, almost like reading the final chapters of a story whose ending has not yet been written. The numbers behind Andromeda's slowdown come from more than a decade of Hubble observations, stitched together from the FAT and FAST surveys between July 2010 and December 2022. Using the ACS instrument and two specific filters, F475W and F814W, astronomers captured light across enough wavelengths to separate hot young stars from their older, cooler neighbors. That distinction matters because color is essentially a stellar clock. Blue light signals youth and active fusion, while redder light marks stars that have burned through their fuel and settled into old age. By mapping where blue clusters dominate and where red populations take over, researchers built a brightness and density atlas that reads almost like tree rings, each layer marking a different era of Andromeda's history. What Hubble's data actually shows is a measurable decline in starbirth over the last several 100 million years, a pattern confirmed across multiple regions of the disk. What remains uncertain is why. One leading idea points to gas depletion, the simple possibility that Andromeda has burned through much of its cold hydrogen reservoir, leaving less raw material to collapse into new stars. Another theory suggests gravitational disruption, perhaps from a past merger or close encounter, redistributed gas away from regions that once sustained vigorous star formation. Both ideas remain active hypotheses, not settled conclusions, and current data cannot yet confirm which mechanism dominates. Zooming out, Andromeda's trajectory fits a broader pattern astronomers have observed across countless galaxies throughout the universe. Large spirals often begin their lives in energetic bursts of star formation before gradually settling into quieter, more stable middle age. Andromeda simply happens to be close enough and clear enough for scientists to watch that transition unfold star by star rather than inferring it from distant, blurred light. That proximity is what makes this story feel personal rather than abstract. The Milky Way shares Andromeda's mass, its spiral structure, and likely its long-term fate. Watching Andromeda's fire dim gives astronomers a rare kind of foresight, a glimpse of where our own galaxy may be headed millions of years from now. It is less a warning than a mirror, one galaxy quietly showing another what growing older looks like.